Hi there guys, got a video here for you today on the AGT Vulcan 3, and what we're going to be doing in this video is making a muzzle brake for the rifle. Now there's three main parts that we're going to be making, and they are the muzzle brake body, as well as the retention nut and the locating boss. At the moment we're concentrating on the retaining nut and the locating boss, and to make these components we've just got a piece of stainless steel chucked up in the 3-jaw chuck. And the first thing we need to do is face the piece and then drill it out to 11.5, which is tapping size for 1/2 inch UNF. We can then give the part a quick chamfer and finally tap it with our 1/2 inch UNF machine tap. With that done, that's pretty much all we can do to the locating boss at the moment. As for all of the other features, we're going to need to reference the 1/2 inch UNF. So we're going to be screwing this piece onto a mandrel and then working from that. But with that done, we can then part the piece off and start work on the retention nut. The retention nut itself is nice and simple. The first thing we need to do is turn the OD down to 27.5mm, then a small step at the end, and this is going to be turned down to 25mm. With those two diameters established, we can then clean up the rear face and put a small undercut in the bottom there, and that will just compensate for any tool radius. When all the components are made, what we'll have to do is screw the locating boss onto the shroud. Then we can slide the muzzle brake body over the locating boss, and then finally capture that with our retention nut. With that said, the next thing we have to do is drill and bore the center out to 19mm, which is tapping size for M20x1. We'll have a male M20x1 thread on our locating boss, and this will be the thread that the nut screws onto. However, with the whole board we can use an internal grooving tool just to create a little bit of relief after the threads. We're going to be single point cutting these threads, so we need a little gutter for the threads to end into. With the waste material removed, the next thing we can do is come back with our boring bar and just put a small chamfer on the lead of the threads. And then finally we can start our threading procedure. Now this is stainless steel and this is a fairly small boring bar, so we're just taking it nice and slowly, plenty of cutting oil, and getting the threads cut to our calculated thread depth. We'll be cutting the matching threads onto the locating boss very shortly, but we don't need these threads to be a super tight fit anyway, so cutting down to a calculated thread depth is fine for this application. You could also use a tap for this, but I don't have an M20x1 tap on hand. But with the threads cut, the last thing we can do is part the piece off and put it to one side. Next up, we're going to be moving over to the body, and the first thing we need to do is chuck up a nice big lump of stock in the 3-jaw. Now this is just an offcut I had lying around, so the OD has already been turned, but that wasn't a critical step for this project. We could have just as easily used a raw piece of material. The stock is slightly over length though, so we're just going to be using our 45-degree chamfer tool just to take about 3mm off the end of the stock. We can check the rough length using our calipers, but we're not getting the part to its final length at the moment, we're just taking off most of the waste material. With that said, we can put a nice finish on the back there, then start work on the internal features. The first thing we need to do is come through with a nice big drill bit. Just drill out to about 25mm deep. We're drilling into what will be the first brake chamber, so all of this waste material will be removed at a later date, but there are some critical features that we need to get established in the end here. To begin with, we're boring the back out to 25mm, and this is just for clearance on the retention nut that we made earlier. We don't want this to be a tight fit. And as you can see here, the retention nut does have a little bit of wiggle room. The next bore, however, is critical. So we're going to be boring the back out to 29.5mm. To do this, we're just coming through with our mini boring bar again, taking the material out just until we get near the rough dimension. What we can do then is bring in a snap gauge, measure the ID, and then take it out to final dimensions. Now technically the actual size doesn't really matter, as we will be making the location nut to suit this diameter. However, it's always nice to be working with round figures, so we're going to be shooting for as close to 29.5mm as we possibly can. As I said earlier, the ID can be measured just using a set of snap gauges, and all these is just a sprung set of plungers which you can preset out the workpiece by just pushing them into the housing, securing them in place using the retention nut, and then what you can do is put the gauge into the hole that you're trying to measure, release the locking nut, at which point the plungers will snap into position. Then you can lightly tighten the retaining nut and move the gauge through an arc just to find the highest point or the largest point of the diameter. You can then come back through with a set of calipers or a micrometer and measure across the two plungers. And as you can see there, we pretty much hit 29.5mm dead on. So I'm happy there. The next thing we can do is finalize the depth of the bore, and this needs to be 7.4mm pretty much exactly. You'll see why when we go to build the part. And whilst we're here, we are just creating a very small undercut just to compensate for any tool radius again. With that done, that's all of the critical dimensions established. We can put a small chamfer on all of the corners, and then using our internal grooving tool, we can come back and create the relief for the head of the nut. So in effect, there'll be a ridge in the rear of the muzzle brake body, and we'll be using the retention nut to clamp the body of the muzzle brake against the locating boss. With that done, the next thing we can do is move the muzzle brake body over to the mill and mill some of the external features. The first thing we're going to be doing is milling the two flats. So the flat on the top and the bottom of the muzzle brake. To do this, we've just got the body set up in the mill with a parallel on one side, and then we're just using a shell mill to mill the top surface off. The across flats dimension will be 40mm, and we need to take just over 5mm off, and that's per side, so 5mm off each side. Now if you look closely, I did have a little bit of a problem getting the calipers under the body of the muzzle brake. What I'd done was I just picked up a small parallel, and without thinking I set the piece up in the mill, but the parallel itself was too small, so I couldn't get the calipers under the part. What I had to do was take the muzzle brake body out of the vise, put in a new taller parallel, and then reset the flat level. We still do have a bit of material to take off of here, so it wasn't a big problem, but it was just a bit of a pain. But with the new taller parallel, we can get our calipers under the piece, take a measurement, then take the piece down to its final dimension for this side, which is just over 45mm. With one side done, we can flip the muzzle brake body and start work on the other side. So we're just cleaning a set of parallels there, putting them in the vice jaws, installing the muzzle brake body, and then tapping it down to make sure it's seated on the two parallels. We can then use our shell mill again just to mill the body down to its final dimension, which again is 40mm across flats. The last thing we can do in this setup is just mill a decorative slot in the top of the muzzle brake. This just helps break up the profile of the muzzle brake and makes it look a little more interesting. To do this, we're just using a 16mm end mill and milling a slot about 1mm deep and 20mm wide. So roughing out most of the material first, then stepping through each side about 2mm, cleaning up the walls and the bottom. And then, as you can see there, it just creates a little decorative finish on the top of the brake. We don't bother with the bottom, as you don't really see the bottom of the muzzle brake. Next up, we can mill the slots in the side of the muzzle brake. So these will be the muzzle brake chambers. And as you can see there on the right hand side, I've already got the front one done. So we're going to be working on the rear one. To begin with, we're using an 8mm drill bit and just drilling straight through the muzzle brake. The brake itself is set up on either side with a little bit of a spacer piece, just to make sure it doesn't move in the vise, and that we can drill all the way through without hitting the bottom of the vise. But as you can see there, just using the 8mm drill bit to drill through the component, then stepping over about 6mm and drilling a parallel hole. These slots themselves are going to be 18mm wide and about 32mm long, so we do have quite a bit of material to remove here. Once we've got our holes established, we can come through with a 16mm end mill and just mill out the rest of the waste material. So going straight through the middle first, then stepping over 4mm each side at a time, just to remove the waste material. Once most of the bulk material has been removed, we can come through with an 8mm long end mill and start milling the side walls. We're going to be milling these in stages, and the first thing to do is just rough out most of the waste material. So in these passes here, we're just coming to about 1/4mm off our final dimension. We're milling the walls in steps, as I don't have an end mill long enough to do it all in one pass. The other thing we could have done is flip the component and work through from each side, although I was a little worried about lining the component up perfectly, so there would be sort of either a join in there, or worst case scenario, the holes would be misaligned. So I chose to just do it in one setup, going all the way through, just to minimise any potential errors. But with the rough passes complete, we can now just finish the walls out. And again, we're just coming through with our 8mm end mill, taking nice light passes across the walls, and stepping down about 20mm at a time. When doing stuff like this, the walls don't always come out perfect, so sometimes you do have to go in there with either a small file or a little bit of sandpaper just to smooth out any chatter marks or anything like that. But once the muzzle brake's been anodised and sandblasted, it is really quite difficult to see any machining marks. Up next, we can move back over to the lathe and finish off the retention nut and the locating boss. To begin with, we're mounting a male 1/2" UNF mandrel in the 3-jaw. Then we can screw on our locating boss and get that done up nice and tight with a set of parrot grips. And then we can face the boss to length, which is 18.5mm, and turn the OD down to 29.5. Now we want a real nice tight fit on the body, so we're going to be roughing out most of the material first, and then just taking a series of really light passes until we get the perfect fit between the muzzle brake body and the locating nut. And then as you can see here, we're testing the muzzle brake body after each pass and adjusting our cut depth to suit. Obviously we don't want a press fit on this piece here, we want a nice sliding fit, but we don't want any play between the muzzle brake body and the locating boss. So we want the body to fit on there really nice and securely. Once we get really close, we can bring over some 1200 grit wet or dry sandpaper and just take any rough marks out of the locating boss and then recheck our muzzle brake. As you can see there, it pushes on. It's not an easy thing to get on and off. You have to get it at exactly the right angle for it to go on or off the boss, but that's exactly what we want. With that done, we can get the other features established, and the first thing we're doing is turning down the end to 20mm for our male M20x1 thread. We could have done this earlier, but I thought if I undershot our dimension, I'd have to remake the component anyway, so I wanted to make sure that we got the perfect OD first, before moving on to the other features. But all we need to do is turn the end down to 20mm, then we can cut our reference face in, and then create a small undercut for our thread. After that we can do one final test fit of the body once everything is chamfered, and to our final dimensions, and then we can thread the end of our boss using our retention nut as a guide for the thread fit. Now I don't want a tight fit on this thread here. In fact, I want a fairly loose thread. I want this to be nice and easy to screw on when everything has been built up. As to actually screw the nut onto the piece, it is a little bit of a pain to get everything in line, and having a tight thread there might make things a little more awkward than they need to be. So we're just cutting the thread a little deeper than I would normally cut it, just so we have that little bit of play between the nut and the boss. With that done, we can mount the muzzle brake body onto the locating boss and get that secured into place using our retention nut. Now I did some work to the retention nut off camera. If you look very closely, you can see a number of holes in the retention nut, and these were just drilled nice and quickly off camera. To be honest with you, I was in a little bit of a rush making this, as I wanted to test it over the weekend, so I didn't capture that part on video. But we've got everything mounted and we're just working on the external features. The first thing we need to do is face the muzzle brake to length. Then we can get a centre drill established in the end of the brake, put our tailstock support in, and then turn the OD to 50mm. This isn't a critical dimension, it's just the nominal size I chose the muzzle brake to be. The shroud itself is 38mm, so we've gone just a little bit bigger. Once we've got the OD established, we can come through and just put a small angle on the back of the piece, and that will just ramp in nicely to the shroud. The angle that we're putting on there is just 30 degrees, and you'll see me checking the back dimension with a set of calipers until we reach our desired dimension. So the rearmost section of the muzzle brake will be 38mm, ramping up to 50, and that will just create a nice blend between the shroud and the muzzle brake. With that done, we can drill the end of the piece out to 11mm, and then drill the baffle in the centre out to 6mm. I did go ahead and make one of the components off camera. I didn't mean to. I set the camera up, started work on it, and I got about halfway through the stripper component before I noticed that the camera was off. So I just made the rest of it off camera, as showing you half the work wouldn't really make sense. But the stripper just screws into the end of the muzzle brake and adds a decorative feature as well as a functional stripper cone. To fit the stripper into the end, we first need to bore the end out to 16mm, about 2mm deep. We can then put a few chamfers on everything and tap the hole in the end of the muzzle brake M12x1. What we can do then is mount the stripper, centre drill it, and then drill it out to 6mm. Then we can get a new centre mark established in the end of the stripper, install our tailstock support again, and chamfer the end. Right then, up until this point everything has been fairly standard. I've made a couple of these muzzle brakes now, and I have made a couple videos on them. I think we made one for the FX Impact and the other for the BRK Ghost. But for this one I wanted to do something slightly different. What we're going to be doing on this one is milling off the sides, and what that will do is just create sort of a trapezoid shape on the front of the muzzle brake, and hopefully it will make it look a little different. To do this work, I've got the muzzle brake set up in my spindexer, the brake is still on our mandrel, and the mandrel is mounted in our collet. What we need to do is set the spindexer to 180 degrees and indicate on the bottom of the component until we get it nice and flat. I did set it very quickly by eye using a level, but we can fine tune the location of the component by simply loosening the collet, rotating the piece slightly, then retightening the collet. We need to do this until the bottom of the muzzle brake is running nice and flat. And then, as you can see there, we got it pretty much close to perfect. We can then turn the muzzle brake over, and as you can see there, the top of the brake is aligned with 0 degrees on the spindexer. What we're going to be doing is cutting an 11-degree taper on the sides of the muzzle brake with the bias towards the top. So in other words, the top of the muzzle brake will be smaller than the bottom. To do this, all we need to do is flip the muzzle brake to 90 degrees, then take off our 11-degree taper. If you take away 11 from 90, you get 79. So that's the position that we need to put our spindexer to. And we do that by just rotating it to 7 on the main dial and then putting our pin in the 9 position. That accurately sets the angle position to 79 degrees. With that all set up, we can get our tailstock support reinstalled into the front of the muzzle brake and start taking some cuts. We're using a shell mill to mill the sides, and we're going to be milling off about 5mm from each side. Now, at this point I was a little worried about the shell mill grabbing the muzzle brake and just ruining about a day's worth of work, so I'm just taking these cuts really nice and lightly. plenty of WD-40 for cutting fluid, and we're taking about 1/4 millimeter each pass. Once we've got one side complete, we can do the same on the other side. So to begin with, we've moved the muzzle brake back to 0 degrees, and that just aligns the top with the top of the mill. And then we can do our same 11-degree offset. This time we go round to 270 degrees, and then we need to add 11 degrees. That brings us up to 281 degrees, and as you can see there, we've got 28 on the main dial, and then the pin position is in the number 1 slot. And there we have it. All that was left to do was mill the other side, and once all was said and done, this is the final result. Now, some people are going to love this look, other people are going to hate it. To be honest with you, I really quite like it. I think it makes the muzzle brake look nice and different, and I will say it will look totally different when it's anodized black. If I was doing another one, I'd probably put some more decorative features on things, maybe a few slots in the side or something like that. But until you've got one made and in your hand, it is really quite hard to tell what's going to look good and what's going to look rubbish. But I'm really happy with that. So what I'll do now is take you over to the bench, we'll show you the final components, and then we'll get it mounted to the gun. Right then, so there we have the components complete. I've roughly deburred everything and got everything ready to install onto the rifle. I will say the body hasn't been anodized yet. I just run out of time this week, so I'll have to get that done early in next week. Don't worry though, you will see it in black when we do our final overview of the AGT Vulcan 3. So if you're interested in seeing it finished, you will be able to see it in that video there. Overall though, I am really happy with how it's come out. It does look rather unique on the rifle. Again, some people are going to really like it, other people are going to hate it, but I really quite like it. I think it looks fantastic on the rifle. With that said, I'll get you a quick look at all the components, starting off with the stripper, this piece here. So, as I said earlier, this part here was made off camera, simply because I forgot to push the record button, but it's nice and simple. What we have is a stainless steel bush with a hole running through the centre, an M12 thread up here, a small taper on the front there, and then a outer diameter here with a hex broached into the end. If we take a 6mm Allen key, we can install that into the front of the piece and then get that screwed into the front of the muzzle brake. Getting that done up nice and tight, you can see the stripper in action there. How much difference it will actually make to the rifle is debatable, as it's pretty far away from the end of the barrel. But when the body is anodized black, it should look nice on the end there. And if it makes it worse, I can always remove it and just put a blank in the very end. Next up, we have the retention nut and the locate emboss. Right then, so the retention nut and the locate emboss are nice simple components. If we take a look at the retention nut first, we have a M20x1 thread in there, along with a number of holes on the outside, which we can install pins into. These pins here just allow us to tighten the retention nut onto the locate emboss when it's installed into the brake. The locate emboss itself screws onto the end of the shroud via the 1/2" UNF in the back here, and then our retention nut clamps the muzzle brake body between these two steps here. So when it's installed, the gap between this edge here and this edge here clamps on the body on this ridge here. So that just clamps nice and securely onto the piece. The benefit of a system like this is that we can angle the muzzle brake anywhere we want it. If we just threaded the back of the muzzle brake, we'd be pretty much gambling to see where our alignment is. You can use things like shim washers and that sort of thing, but using a system like this, you can adjust it for any rifle. And whilst it's a little bit of a pain to set up, once it's set up, it's nice and easy. With that said, if we take a look at the locate emboss here, we did go ahead and just mill a small square in the end there, and that just allows us to put a 3/8 ratchet drive in there to either tighten it up onto the shroud or remove it if we ever needed to remove it. And then on the back there are a couple of holes if this piece and the retention nut ever get stuck into the back of the muzzle brake body. With that all out of the way, the next thing we'll do is fit it to the rifle. Right then, to get the muzzle brake fitted, it's nice and simple. The first thing we do is install our location boss, and that just screws onto our 1/2" UNF. And then that can be tightened using either a 3/8 ratchet or a breaker bar, something similar like that. We can then take our muzzle brake body, make sure that there's no debris inside this bore here, and then get that pushed over. With that done, the next thing we need to do is install our retention nut, and that just goes into the first chamber, just like so, and then screws onto our locating boss. This is the primary reason why I didn't want this thread here to be super tight, as with it being a little looser than normal, it's nice and easy to spin into position. And then once we get it started, we can just bring over an O-ring pick or something similar and spin it into its final position. The next thing we can do is just level the muzzle brake. So we can just spin that into position, just roughly at first. We can then tighten our nut so it's just gripping, and we can bring over something like a little level, get that leveled by eye. The next part is a little fiddly because I'm using pins at the moment, but I am going to be making myself a proper tool to do this. But what we need to do is install these pins here into the retention nut, and we're going to be doing that just with a set of tweezers. And we can get the brake aligned and then done up with something that goes between the pins and that we can use to tighten the brake. And there we have it, that's pretty much it. With that all said and done, that's pretty much going to do it for this particular video. Obviously the muzzle brake needs to be anodized, and you will be able to see the finished article when we do the final overview for the AGT Vulcan 3. I'm really looking forward to seeing it anodized, and I think it's going to look fantastic. With that all said and done guys, that's pretty much going to do it for this video. I hope it's been interesting. Thanks for watching, and we'll see you in the next one.